morning to everyone. Myself, Dr. Jaishree Jain, Associate Professor in Ajay Kumar Engineering College, Ghaziabad. Today, I am going to give the lecture on the introduction to cloud computing. That is, the subject is cloud computing, KC 713. So, firstly, we have to just learn what do you mean by cloud and what are the different services that are provided by the cloud, and as it is the introduction of the cloud computing, so we will learn what are the methodology and what are the different terminology used before development of the cloud computing. So in this lecture we will learn about the evolution of cloud and definition of cloud computing, and after that we will learn what are the different advantages and characteristics of cloud computing and what are the disadvantages of the cloud computing. So we will learn basically introduction to the cloud computing. So we can say what is the cloud computing, what are the different views of different authors, then evolution of model computing, then logical evolution of the computing, evolution of sharing on the internet, fundamentals element of the cloud computing, and 5 characteristics of cloud computing plus pros and cons of cloud computing. So we will learn about these terms. So what is cloud computing? As you know the term cloud, we can use the abbreviation of cloud like C represent as common, L is for location independent, and O is for online. U stand for utility, that is available on demand. So we can say cloud services are very common, that is available to all, and location independent. As you know, cloud services can be accessed at any location. Because we can say cloud is what? Cloud is internet of internet, that is a combination of internet, and cloud is going to be deployed at any physical location, and there are certain providers which are going to be provide the services. Services what? That are the resources, like I required processor, I required memory, because my system have low memory, and I have required some storage, like we currently we are using Google Drive. So we are going to store our data over the Google Drive, so we can access our data at any location. Now need is only for internet. So this is, we can say cloud services are common, means anyone can upload their data over the cloud, and that is location independent and online. So online means we have to connect with the internet, after that we can access the services. Utility, that is available on demand. So what is mean by utility? Utility means the resources are being deployed, and there is a resource pool where all kind of resources are kept in that pool. So we can say there is a rack space, motherboard spaces are there, and on the rack space we have equipped the storages devices like hard disk, RAM, and CPU, processors, and other resources, like we can deploy different virtual machines. So utility means services are available. Now you have to just subscribe or take the service, and you have to pay for that service. So overall we can say this is the main part of the cloud, and main definition is, so cloud we can say come from the early days of the internet, where we drew the network as a cloud. So we can say, as we have to know, there is a client server system exists before the cloud computing came into the picture, and all the network is distributed. So we can say that cloud is a network. We didn't care where the messages went, cloud hid it from us. So we don't know where the services are going to be deployed, because these services are deployed at any physical location, but we are going to use it virtually. We are going to use it at online platform. So first cloud around the networking, second cloud around the document. So we can say when cloud came into the picture, firstly TCP IP abstraction is there. Like first cloud around networking means only while connecting with the internet we are going to access the data or share the services. And in second case, that is www data abstraction, means all kind of services going to be published on the web, and when we published our service over the web server, then we can say there is a particular domain and any user can access or register to that domain, like Amazon AWS or like IBM Watson tool is there, and Microsoft OneDrive. So these are the examples. So all the document is going to be abstracted over the cloud. So this is the main definition, and we can say cloud is an emerging style of computing in which applications, data and resources are provided as a services to the users. So this is a diagram where we can say services provided may be available globally, always on and low in cost and on demand. So basic is utility, means is that services are available on demand and you have to pay according to you grow, and services are scalable also. Fine. So this is a diagram. So we can say like we have the cloud administrator here, and just wait. So we have cloud administrator and we have component library. So this is a one cloud, as we know this is a cloud shape, and we have to deploy the data centers first, because there are number of billion user which are going to take the service of cloud. So all data is going to be stored over the cloud. So there will be requirement of a large data centers. So these all data centers are here in line. We have to put these data centers, and cloud administrator is who have deployed this cloud and who have the control to access that data and to provide the services to the user. So he or she will monitor and manage the resources, and this is a client which is going to access the services, and this is the user that is going to be publish and update the component. So this is the one team member which are going to be publish the services over the World Wide Web. And this is the library, means all kind of library support or driver are going to be provided to this data center. So basic characteristics of cloud, we can say, what are the basic characteristics of cloud? Pooling of the resources. So all the resources are get pooled into the one place, one center. Network connection. So there will be requirement of the network connection first. These those resources or our we are going to use our PC. So when we connect our PC to the Wi-Fi or LAN cable, then we can access to the via browser, we can access to any website. So network connection means all these resources should be connected, should be distributed over the network. So network connection is important. On demand services means resources are going to be provisioned. So there are special kind of CPU where CPU can be divided, or we can say provision in among the different virtual instances. Like I have deployed all services at one center, and we have rack space of the motherboard and different storage devices. Then we there is a control layer. So we have to just divide these all the resources to the different virtual instances. So there is a one physical machine, and we have made different virtual machines over there, and we provide those resources to the different virtual machine. After that all kind of system software and application software are going to be deployed on that virtual machine, that is based on the requirement of the user. That user is going to take which service, infrastructure as a service, or platform as a service, or software as a service. If user is going to take infrastructure as a service, then that VM virtual instance will going to be provided to the user, and user can install or can install their software accordingly based on the user requirement. But if user is going to be take the service of platform as a service, then virtual instances will already deployed and system software will already deployed. Only user have to deploy their applications, or because all kind of library support or driver will already deployed at provider, and only user have to, for example, user want to host their website over the net, over the web. So only user required one kind of platform, so that like GitHub, so GitHub is going to be provide one kind of platform to host our website. Fine. So this is a service of platform, like Google App Engine going to provide the service of web hosting. So these all kind of service are depending on the service, and at top level we have software as a service. So software as a service means we are going to use online software. We need not to install and buy the license of the software on our PC. So if I want to use a MS Office 2000 20, so I can 2015, so we can use it directly on the cloud. So these all kind of services we can choose over the cloud, but condition is pay as per the use. And last one is the metered services, means all kind of resources are going to be measured and user have to pay according to the usage. Fine. So this is a basic characteristics of cloud computing. So we can understand what is the essential of cloud. Cloud is basically a strategy and it is not a technology. So we can say it is a strategy. So what is cloud? Is a metaphor for the internet, and the basic definition of cloud is the use of internet for tasks you perform on the computer. So user point of view, good cloud computing is definition is using the web application or server services that you pay to access rather than software or hardware that you buy and install. So there is no need of installation, you have just pay and can access the resources. So we can say cloud environment is what, where these all computing are going to be merged, like on demand computing is going to be merged, utility, all services are going to be merged over the cloud. Green IT means the cloud services are, we controlled, if we deployed multiple servers, then the ecosystem will also get disturbed. So we have only one physical server over which we have deployed different virtual machines. So we can say the CO2 or the that is pollution of in our ecosystem is going to be controlled when we use a single server over which we have different virtual servers. So we can say it is a green part of green IT. And automatic computing is there, as I already told, the resources are scalable. Like we can take the example of Gmail. Gmail gives you the basic storage of 15 GB, but when the mail of in your inbox is going to rise, or you are going to attach more than 15 GB file, then you have to that space can be grow, or it can be free, or either you have to pay. Fine. So scalable resources, when automatic computing is there, resources will already get added, and the storage will be more. So this is the basic of cloud computing. And fundamental elements of cloud computing are what? So we can say if we are going to deploy the cloud server and using the computing services, so we can say it is universal. It provides the universal connectivity, open access of the resources, reliability is there, interoperability and user choice is there, then security, then privacy, economic value and sustainability. Sustainable means resources are going to be sustained over the cloud server. You need not to bother about the means your data loss will be 0. So your data will remain sustainable economically. Resources are good, means there is no more cost. You just have to register and thus you can use the resources. Privacy and security is there, as you have login ID and password, and you just have the access control over your data also. Interoperability and user choice, you can use any browser, you can choose any platform, and you can access your data in easy manner. So next is 5 characteristics of cloud computing are resource pooling. First is the resource pooling, already told that resources are going to be pooled at one place. On demand self-service, as user can choose among the different virtual instance, can take the service. Metered by use, and elasticity is there, and scalable. All the resources are scalable. So as per the user need, resources can be added or can be removed. So there are 5 essential characteristics of cloud computing: on-demand self-service, broad network access, rapid elasticity, resource pooling, and measured services. Okay, so we have on-demand self-service, broad network access. Already I have discussed these characteristics. So these characteristics are very important, and already questions come into the exam. So this is very important part. And evolution. Next is evolution, means trends in trend in computing. So before cloud computing, there will be a distributed computing and grid computing, cluster computing, utility computing, and after that we have cloud computing. So distributed, I think we all know what is the meaning of the distributed computing. So we will discuss these computing one by one, and the question can come in the form of like difference between distributed and grid computing, or grid computing and cloud computing, and all that. So this is another evolution. If we can say, in 1960 to 70 we have mainframe system, and after of IBM. After that we have mini computers like in 80 to 85. So this is the evolution developed by DEC and Intel PC 1985 to 90. So this is a one kind of evolution. Then client server system of Microsoft Sun Systems, Cisco give us IP networking, IPv4, IPv6, and Nokia mobile services is there. And then we have cloud computing, Salesforce.com and Amazon and Google. These are our example of different providers. So mainframe system, we already know, at starting we have the big computers, large organization for critical applications or bulk data processing and all that. Then cluster computing, that is started in 1990. Cluster become the standard. So cluster, as you know, the name is cluster, means there is a group of system that are interconnected with each other via LAN, and those systems are going to be connected with the internet and going to be connected with the distributed network. So already all the data will be divided into different client PC and will be merged at the server end. So next is load balancing clusters are there, high availability and high performance cluster. So when we made the cluster, performance will be high as the task is going to be executed parallelly, and load balancing of the cluster, because if there is a load on the server, then we have just divided the resources to the, we have divided our data into different PC, so that they can there can be computation in parallel form. So this is a part of distributed computing. In distributed computing, actually each system, each personal system have its own logical clock, have its own memory, have its own processor. So each system has its own memory and all processor, and internet work, these all system will be connected with the internet, and we have they are going to be communicated via the message passing system. So this is one system, one PC is there, one PC is there, and one PC is there. So these are different clients which are connected with one system, and they are going to be shared their data via message passing. Next is distributed computing, so and grid computing. So distributed computing refers to the multiple system working on a single problem, and in this single problem is divided into many parts, and each part is solved by the different computers. Fine. And in grid computing, actually it is a technique in which ideal system in the network and their wasted CPU cycle can be efficiently used by the uniting pool of server. Means in grid computing, that is one step ahead from the distributed, as in distributed computing only files or data is going to be shared so that computation can be done parallelly. But in case of grid computing, we have all the resources shared over the network. So these resources are, we have pools of servers or storage system and network into a single large virtual system for resource sharing dynamically at runtime. So at runtime, we have different systems. Those are connected via one grid, and in grid we have one server, pool of servers. So according to the requirement, we have assigned like one server for this purpose, other server is for different purpose. So we have divided servers among the different users, and according to the need of the user, those server are going to be shared, and storage system is going to be shared, and network. Fine. So we can say grid computing can be used in the on premises, or it can be useful in a corporate sector where there are 1,000 employees. So we required a grid so that their data that is going to be at different, there are different headquarter is there and different branches of the company is there. So all data can be segregated and can be integrated at one place. So we have one grid, means like we have Reserve Bank of India, we have one server, but all the city wise all the branches are going to be divided, and the data is going to be divided on the different servers. So like resource sharing is main purpose of good grid computing, and coordinated problem solving in dynamic and multi-institutional virtual organizational, means we have different in education sector, we can say we have different university collaboration, or we have different institutions. So those institutions can club their servers at one place, and all data is going to be integrated by AKT University. So this is a part of grid computing. So this is, I already discussed. So this is the example of grid computing. We have a supercomputer or mainframe, and these are the system, Linux operating system and Windows operating system or network, and there is a hub through which all these devices are going to be connected, and one database. So all the system in the network access the common database. So database is common data center deployed at grid like at single server, and all the devices and all the server are going to be connected with each other. So this is model of internet grid with common database. So next is utility. Utility involves the renting of computing resources such as hardware, software and network bandwidth on and as required. So utility is one step ahead from grid, as it have the metered services, use the meter service, and have provide the resources on the rental basis. So it is not distributed now, it is the centrally controlled. Fine. So the computer utility is a service provisioning model in which service provider make the computing resources and infrastructure management available to the customer as needed. So utility means on demand services are going to be divided among the different servers, and basically as per the need, and customer have to be charged, customer have to pay for the for that resource. Fine. So we can say, take the example of utility, like we have we have electric meter in our house, and already wire is going to be deployed there, and we have electricity house from which we are going to be gaining the electricity, and we have to just pay what is the consumption of our electricity. So next is cloud computing evolution, pros and cons and distributed system. So we can say pros and cons of cloud computing are, which point are plus, like cloud computing is encapsulated change management. So we can say all kind of complexities hidden from the user, and the management is centralized. So only all services are going to be managed by the central server. And there is next generation architecture, choice and agility is there, scalable and economic value is there. And what are the cons? Lock-in. So lock-in means when you take the service, you have to just uh, take the subscription, and that subscription will be valid for some time period. So that is lock-in, your data get logged at that uh, service at the server. And next is reliability issue is there, because user didn't know where his or her data is going to be stored. So there can be reliability issue. And lack of control, user have no control of their on their data. And security issues. So these are all the research topics, security of the cloud computing. So we can say these are the cons of the cloud computing. Then distributed system. So centralized versus distributed. Centralized means all the system are going to be connected with the one server, that is centralized. And distributed means each system have it on server, means this system and this is this storage system and data center, system data center, and these are all interconnected with the network link, means they are going to be share their data. So this is distributed, this is centralized. So we can say this centralized is a part of cloud computing, because in cloud computing only one main server is there at center place, and all the provider is going to be provide the resources to the user. And this distributed is a part of grid, as grid is deployed and has divided the resources into different devices. So distributed means it is a collection of independent computer interconnected via the network, capable of cooperating in on a task. So distributed system means collection of independent system. So we have already choose different independent system, and distributed system can be characterized as a collection of multiple autonomous computers that communicate over a communication network. So we can say each system, there is no physical clock, because each system has its own logical clock. Enhance the reliability, as one system is failed, then other system will remain as it is. Increase the performance, access to the geographic remote data location, and scalability. These are the features of the distributed computing. So this is a system of distributed computing system. Each system have its own processor and memory, and these systems are all interconnected. So we can say this is a part of distributed system. And there are autonomous computing, and as per the, we can say reliability and performance is better. So motivation is resource sharing, access to the geographical remote location, and the reliability. And this is the architecture of distributed system. So we have internet at the center, and we have ISP like Jio, Airtel, Idea, and through which different server are going to be connected, and through ISP we can directly take the service of, we can directly can deploy the one Wi-Fi, and this ISP is going to be provide the Wi-Fi router, and as we have in our home Wi-Fi router and going to be take the service. And so we can say this is the architecture, wireless internet service provider, and the system are connected at wireless means Wi-Fi, through Wi-Fi, and this is through LAN. And we have the system architecture like processor memory, and processor memory system is interconnected with each other. Loosely coupled system, as processor do not share the memory, and each processor has its own local memory. So we can say distributed system are loosely coupled, and like these are connected with the communication network. So this is a bus topology, and they will going to communicate via the message passing. So this is, we can say this is a loosely coupled network. And examples of distributed computing are telephone network, computer network, ATM banking, distributed database. Okay, so these all are the examples. And so we have example of automated teller machine, and like we have different ATM machines. and these ATM machines were controlled with the central ATM machines. And next, these machines, all the transactions are going to be hold on the central data center, and these are the hot stand holding a secondary copy of bank account data. This is a replica, or we can say backup of the server. Common property of distributed system are fault tolerance, each node play the partial role, resource sharing, load sharing, easy to expand, and the performance. So these all are the common, as we have fault tolerance. If one system is going to be corrupted, all system will work as it is, and each node play a partial role. So we have divided our data. So computation is going to be done at partial way. Resource sharing is there, and load sharing is there. Easy to expand means we can add more nodes on the distributed network, and performance means the we are going to be, this computation is going to be done in parallel way. So we can say performance or throughput of the system will be very good. So thank you so much. We will continue in next lecture.